Hi, today I want to talk about the ESP32 and the mesh development framework. You can use this with the ESP32 and the Bluetooth and also Wi-Fi and ESP Now functionality. And beside the ESP32 and the development platform, you also need a mobile phone to start an app and just control all the ESP32 mesh nodes. So why ESP-MESH, you ask maybe? If you have a look at the classical router connections, you can see that all the ESP32s have a connection between the router and the internet. So you can have a one-to-one connection and the router is maybe some kind of gateway to the internet, or also a way to communicate from one ESP32 to another. But if you have a look at the mesh network, then you can see that all the nodes can talk between each other and only one, the root node, have a connection to the router, and all the communication is routed through the root node. And also you can extend your mesh network above the boundaries of the reach of the router. So in the classical network, you only can use the nodes that have a connection to the router and all other nodes are not connected. But with the ESP-MESH, you can extend your network above the boundaries. And this is what we have. And here's some picture about the architecture. You have the root node, then you have a secondary layer nodes and also the third layer nodes. So all the communication goes through the second layer and then through the root node. Maybe this picture is a little bit better. So we have a root node, intermediate parent nodes, and also above the boundaries, the leaf nodes, because this is all in reach of the router and this is not in reach of the router. And we have also maybe some idle nodes that not communicate with the mesh network. And that's it about the mesh network in a nutshell. First, I start with the get starting guide for the MDF, and you find this in the GitHub repository under docs, and then go to EN and read the README file and then go to the get started page. First, we download the ESP-MDF or mesh development framework from GitHub. So we switch to the GitHub page, clone the whole repository from GitHub with git clone. And then we just set some variables, command line variables. I use the MDF path in my Ubuntu installation and also the IDF path. And in my case, I don't install the tool chain with the MDF. I just use my regular IDF tool chain. And now we can start with the light bulb example, and I copy this to my workspace path where all my examples are stored in. And then we start by typing in make menu config. Now we can set some general parameters like the SDK, tool configuration, the bootloader config, security features, and more important, the serial flasher. I set my to USB TTY USB 0, and also the serial flash speed I crank a little bit up to the highest speed that's possible for me. Then we go to the light bulb configuration and I switch to the other board, and we can also have a look at the ESP-MDF configuration, but I'm not setting here any special parameters. But we can maybe change the key configurations for the ESP Now. And then more important for me, the partition table, because in my example, this example don't get flashed and don't work. So I have to change the partition table a little bit, but show you more later. And then just go to exit. And so now let's have a look at the partition table, and I have to increase the flash size for the factory partition and shrink a little bit for the OTA and 0 and 1 partition. And we can have a look in comparison to the original espressive example. And as you see, the factory is just 576K and the OTA partitions are a little bit bigger, but I have rearranged them. And let's compile the code, and I type make -j and the number of cores you have +1, and we entered the target all. And after a while we can see all the compiling output and wait just for the binary files that are built at last. And now we flash our new builded binaries to our ESP32 just by typing make, and we can also erase the flash. So I type erase flash and also flash and monitor, so we can see on the serial output what's going on in the debug mode. So in my case the ESP32 is not on TTY USB 0. I have to plug it out and plug it in and use dmessage to see if my ESP32 is now ready to flash. And then I try it again, and as you see the flash goes on, and after a while we are successfully flashed our ESP32 with the new mesh example, and then we can see on the output what's going on. And on the output we can also see some general parameters, maybe like our silicon revision of the ESP32 chip. And now we can use the mesh application from Espressif to see what's going on. And I've flashed the firmware to 2 ESP32s, as you see on my bench. And so we can have a little look what's going on with 2 devices. And as you see, we can also change the color of this light bulb example. So the values of the colors are transmitted to the ESP32, and then we steer the GPIO pins. And sure, you can set different colors individually for each ESP32 light bulb example and change the colors whenever you want. And here we see the output windows of the both devices, and we can see that all the transmitting steers the internal HTTP server from the ESP32, and the values are set accordingly. Thanks for clicking and watching my video. I hope you enjoy it and hopefully learn something. If you have some questions or comments, please write it down in the comment section. Like and share my video and subscribe to my channel. And for some reasons I also set up BitChute and Minds and Gap account. Yes, I want to do a little bit special and exclusive content for BitChute, so join just my BitChute channel, so you can also see some informations about my channel with the links below. So I wish you a nice day, see you next time, and bye bye.